Today we will be studying about MOT. Okay, MOT means molecular orbital theory. MOT means molecular orbital theory. MOT means molecular orbital theory or Hund's mulliken theory. Hund's mulliken theory. Okay. This theory was proposed by Hund Mulliken. This theory was proposed by Hund Mulliken in 1932. This theory was proposed by Hund Mulliken. Hund and Mulliken. Hund and Mulliken in 1932. Okay, and later on it was developed by I.F. Leonard Jones and Colchian, and later on it was developed by I.F. Leonard, I.F. Leonard, I.F. Leonard and Colchian okay. According to BBT, overlapped orbitals exist in the direction of the bond and are localized between the two atoms, forming a bond. Thus, the bonded electrons localized between the bonded nuclei. Okay. According to molecular orbital theory, MOT, each electron moves in a delocalized orbit which includes all the atoms of molecules. Okay. According to MOT, according to MOT, each electron moves in each electron moves in a delocalized orbit which enclosed all the atoms of molecules, all the atoms of molecules, okay. Nuclei of the bonded atoms remains at the bond distance while atomic orbitals overlap to give molecular orbitals MOS, which spread over whole of the molecule. In this way, all the orbitals of an atom contribute to the formation of a covalent bond in a molecule. Okay, it considers the complete interaction between the electrons in atomic orbitals. Then the BBT, the molecular orbitals are filled according to Aufbau principle, Pauli exclusion principle, and Wood's rule. Okay, according to MOT, the nuclear orbitals are polycentric. Okay, the formation of molecular orbitals by combination of atomic orbitals is you can show also salient features of MOT. Salient. 1 minute. This is the nucleus. Okay. This is the nucleus. This is K orbit. This is L orbit, and this is M orbit. Okay. And you can show this is nucleus. This is nucleus, and this is K orbit. This is L orbit, and this is M orbit. Okay. So This is in between this non-bonding, 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 and you can show, okay, and this is psi A equal to psi A minus psi B, psi A minus psi B, okay, and this is psi B, psi B, psi B, okay, equal to psi A plus psi B, psi A plus psi B, and this is also converted in a okay, this is A and this is B, and this condition is satisfied that anti-bonding molecular anti-bonding molecular orbital higher energy. This is higher energy, okay. This is ABMO, that means anti-bonding molecular orbital, okay, and this condition is bonding molecular orbitals, bonding molecular orbital, bonding molecular orbital, lower energy, okay, lower energy, BMO, lower energy, BMO, okay, and this is ABMO, okay, that means anti-bonding molecular orbital, okay, ABMO, this is ABMO, okay. Psi A equal to psi capital A minus psi capital B. This is a non-bonding, and psi B equal to psi A plus psi B. This is energy, or atomic orbital A, and this is atomic orbital B, bonding molecular. This is ABMO and this is BMO, bonding molecular BMO orbital, okay, molecular orbital for every molecule, molecular orbital for every molecule, okay, every molecular orbital for every molecule, okay. The fundamental characteristics of MOT are given as follow. Okay, we can show first point. When the nuclei of two atoms come close to each other, their atomic orbital combine to form molecule orbitals. The atomic orbitals lose their identity after the formation of molecular orbitals. First point. Second point. Molecular orbitals are formed by the combination of atomic orbitals AOS. AOS, atomic orbitals, okay, of nearly same energy, and MOS, molecular orbitals, do not belong to a particular atoms, but they belong to nuclei of all atoms constituting molecules. Fourth point, there must be sufficient overlapping between the atomic orbitals. The electron density between atoms forming the bond will be greater due to greater overlap. Fifth point, each molecular orbital is described by wave function psi called MO wave function. Psi square presents the probability density or electron density. Sixth point, the shape of MO molecular orbitals depends upon the shape of combining atomic orbitals. The number of MO molecular orbitals formed is equal to the number of atomic orbitals undergoing combination. Half of the MOS are of lower energy bonding molecular orbitals and other half MOS are of higher energy, that means combination AO anti-bonding molecular orbitals ABMO. Electrons are attached to fill the MOS in the same manner as they fill in the atomic orbitals, obeying above principle, Pauli exclusion principle, and the Ohm's rule of maximum string multiplicity. Is that molecular orbitals are filled in the increasing order of their energy. Okay? Each molecular orbital contains only two electrons having opposite spin, plus 1 by 2 and minus 1 by 2. Okay? Molecular orbitals. 1 minute. Salient features. Salient features of MOT. Salient features of MOT. Salient features of MOT. First point. When the nuclei of two atoms comes closer to each other, their atomic orbitals combine. Atomic orbitals combine to form molecular orbitals. Okay. When the nuclei of two atoms comes closer to each other, their atomic orbitals combine to form molecular orbitals. Okay. Next point, second point. Okay. Molecular orbitals. The atomic orbitals lose their identity. 1 minute. The atomic orbitals lose their identity. After the formation of molecular orbitals. Okay. Second point, molecular orbitals are formed by molecular orbitals are formed by molecular orbitals are formed by the combination of atomic formed by the combination of atomic orbitals AOS, okay, of nearly same energy, okay. Molecular orbitals are formed by the combination of atomic orbitals. Molecular orbitals are formed by the combination of atomic orbitals of nearly same energy. Okay. Third point. MOS molecular orbitals do not belong to a particular atom but they belong to nuclei of all atoms constituting molecules. Okay. MOS molecular atomic orbitals do not belong to a particular atom, but they belong to nuclei of all atoms constituting molecules. Okay. 4 points. There must be sufficient overlapping. There must be sufficient overlapping between the atomic orbitals. Okay? Atomic orbitals. There must be sufficient overlapping between the atomic orbitals. There must be sufficient overlapping between the atomic orbitals. The electron density between atoms the electron density between atoms forming the bond will be greater due to greater overlap. Okay? There must be sufficient overlapping between the atomic orbitals. The electron density between atoms forming the bond will be greater due to greater overlap. 5. Each molecular orbital is described by each molecular orbitals is described by a wave function psi, a wave function psi, wave function psi called as MO wave, called as MO wave, MO wave function, wave function. Psi square represents the probability density. Psi square represents the probability density. Probability density or electron density. Each molecular orbitals is described by a wave function psi. Each molecular orbitals is described by a wave function phi called as MO. Each molecular orbitals is described by wave function psi called molecular atomic orbitals. Wave function psi square represents the probability density or electron density. 6 point. The shape of MO molecular orbitals. The shape of molecular orbitals. The shape of molecular orbitals depends upon the shape of combining atomic orbitals. 7 point. The number of molecular orbitals. The number of molecular orbitals formed is equal to the number the number of molecular orbitals formed is equal to the number of atomic orbitals undergoing combination half molecular orbitals are of lower energy bonding molecular orbitals, that is bonding molecular orbitals BMO, and other half molecular orbitals are of higher energy the combining orbitals energy then combining atomic orbitals anti-bonding anti-bonding orbitals. Okay. The number of molecular orbitals formed is equal to the number of atomic orbitals undergoing combination. Half of molecular orbitals are of lower energy BMO, and other half of molecular orbitals are of higher energy than combining ABMO, anti-bonding molecular orbitals. Okay, this is bonding molecular orbitals and this is anti-bonding molecular orbitals. Okay. 8 point, point 8, 8 point, 1 minute, point 8, 8 number. Electrons tends to fill the molecular orbitals. Electrons tend to fill the molecular orbitals in the same manner as they fill in atomic orbitals. They fill in atomic orbitals, obeying above principle, Pauli exclusion principle, and the Hund's rule of maximum spin multiplicity, multiplicity is that the molecular orbitals are filled in the increasing order of their energy. Order of their energies. 9 point. Each molecular orbital electrons tends to fill the molecular orbital in the same manner as they fill in atomic orbitals, obeying above principle, Pauli exclusion principle, and the Hund's rule of maximum spin multiplicity. The MOS molecular orbitals are filled in the increasing order of their energies. 9 point. Each molecular orbitals contains only 2 electrons. Contain only 2 electrons having opposite spin. Spin is that +1/2 or -1/2. Okay. Thank you. Next is molecular orbitals. What is molecular orbitals? We will be also known about molecular orbitals and formation of molecular orbitals and electronic charge density of molecular orbitals, atomic charge density of molecular orbitals, and condition for the formation of molecular orbitals, and the type of molecular orbitals, and difference between bonding and anti-bonding molecular orbitals. Okay.